This time on Captain Castle Laboratory, we're going to see what we can do with this Department 56 village accessory, Escape from the Crypt is the name of it. So, this is a 12-volt AC unit. It has the hook and flying skeleton, which I have no idea where he goes on here. I have to look at the picture. Skeleton's pretty cool. Yeah, look at that. That's some good detail right there. Anyhow, it's supposed to spin, and it doesn't. According to the picture, it looks like it hooks in his rib cage. Yeah, that would make sense. There's a hole in his rib cage. So, like right there, like so. There we go. And then this is supposed to spin, but two problems. One, motor doesn't spin. Two, I think the top of this is broke. We're going to find out. So first thing I'm going to do is, so we don't damage this, it's resin, so there is flex, but at the same time I don't want to break it, so I'm going to put him up and out of the way. So when I got it, as soon as I took it out of the package, the bottom fell off, so I'm assuming the owner took the base off, and that's fine. So I'm going to go ahead and lift it up and tip it, so, and then I'm going to plug this in. Motor is humming, but this isn't turning, so there's no motion. So very common thing is just motors. They'll still spin and try and do their thing. It's what happens is right in here is what breaks, right where the center pin is. The armature usually breaks. Sometimes you can open it up and fix them. Sometimes you can't. But my concern is how does this spin? Normally, like this gooey stuff in the middle would have a slit, but I can't find a slit that would pop into. Pretty cool looking piece. There's no circuit board, as you can tell here. We have some resistors soldered to a, looks like a transistor. No, it's not a transistor. It's a bridge rectifier. So this is a full bridge rectifier, which converts the AC into DC so the lights work correctly and they don't flicker. And they're direct wired. And then they just use resistors to resist the 12 volts down to the appropriate 2, 3, 4 volts that they run. The only thing that runs at the full 12 volts is this motor. And I'm assuming this is a universal base, because if you can see in the camera, you have mounts here and here, mounts here and here, and that this is at an angle. So it's see, level, angle. Pretty interesting. So this is probably universal base. Some of these older pieces use number 2 screws instead of hobby screws, so I keep grabbing that and it doesn't do anything because it doesn't fit in the hole. It's too small for the hole. So I'm assuming this is a 12 volt motor. Yep. So it's AC 12 volts, 60 hertz, 3 watt, 3/4 RPM, CCW. Problem you're going to have is most of the replacement motors are not the same power. That's kind of interesting. You can see the holes for venting, or if it was for a speaker originally, it is cast into the bottom. So, but this looks like a universal mount. So that's kind of neat. Next is trying to get this off so I can see what's underneath it and what it's supposed to do. It's glued to the motor. There's a glue seam all the way around. Here's some of the glue. Probably doesn't help that they got this hard resin glue over this center pin. The pins technically shouldn't move, but if the glue before it cured ran down inside, that could shorten the life of the motor. This is an older piece, so I don't think it did that to this one, but maybe some people who bought these when they were new may have experienced some issues. I might have to heat that up, This is feels like a hard plastic. So I'm gonna see what I can do first. If it doesn't separate, then I'm gonna heat it up. There we go. So there's our hole. This end has something in it. That piece is really good. There is actually liquid grease as I squeeze on this oozing up. So I think, and that's weird because this thing's cold. I mean, it's room temperature, which is like 70 some odd degrees. It shouldn't be oily. So we're going to keep these pieces out. I have a stack of 12-volt motors to replace this with because they don't make the motor for this anymore. So we're going to have to do a little modification. So I have a threaded flat, two-sided flat shaft. I have a non-threaded D shaft. I have another two-sided shaft with a smaller hole. I have a smaller motor with a longer shaft. So these are 50s, this is a 40. And then I have another one, which is a teardrop synchronous motor. Go. And it is, these are all 12-volt AC. Some spin counterclockwise, some clockwise. Doesn't really matter on things like this. If it spins the other direction, it doesn't affect the function of the piece. So you can see all these shafts protrude, and that one doesn't. But you know, I can do something like this where this slides over, and then we can fit this back inside. So that's what I mean. We're going to have to do some modifications. We're going to have to see which of these will work the best. Since this, that they don't make anymore. This looks like it might work. Either one of these two. The D shaft, I think it's going to be too tall up inside the green. The D shaft is... These two are the same height, so I think we're leaning towards this one. It's definitely too tall. And not enough grip. So knock that one out. That one's too small and too short. So I think we're going to be stuck with trying to modify this one here. So this fits down. So this barrel that was glued on goes around this outer bushing area right here, or it's not a bushing, the bushing's on the inside. This one protrudes, it's not as tall, but this fits around and still fits flush with the bottom. So there we go, that's a positive. Now this, to make it work, I would probably, we're going to have to do this. It's probably going to stick up a little too high, so we're going to have to do some trimming. You can see it protrudes out. It should be relatively flush. This green thing is a bushing. All this is designed to do, it's not supposed to spin. It's designed that this can spin internally and that the material is soft enough it's not going to wear out by rubbing the resin base. So you do need a bushing. If you modify the green to fit your new style motor, so be it. I might have to modify the hair because the green is just, I don't know if you can see in the camera, the top of this goes right into this taper, and that's why it doesn't sit against the motor. You can either cut the top of this off, which is noisy and annoying, or you can try and bore that hole out just a little bit. You only have to go a small depth. So, and you can see how thick the green is. So there's enough room to put a little bit of a drill bit or sander in there and auger it out for this. Now it's AC, so it doesn't matter which wire is connected to which. I'm just going to cut them. Normally I would desolder them, and the reason I'm not going to desolder them is when you have a whole bunch of other things attached to it at the same time, everything desolders. So if I cut it back, I can just solder to a small piece of the wire and then have the solder run into the original solder. That way I don't have to worry about the rest of it coming off. So, let me cut the one here and here. So, and we're going to get rid of this motor. If you want to try and find this motor, maybe somebody has one in stock somewhere that's a new old stock. It's a JC 905B. So you can go do Jim Carrey -905 boy. And the motor I'm going to replace it with is a TYD-50. The TYD motors or the TYC motors, there's two, are the most common motors out there. So this motor also sits a little bit higher. That might cause a problem too. Ooh. I didn't take that into consideration, was the height of the motor. My bad. So these are TYCs, and you can see they're a little bit shorter. See, TYC. So technically, out of all the motors I have, this one is the only one that's going to fit. So scratch everything I said, back to the drawing board. So we're going to have to make that work. That'll still work fine. It actually fits around perfectly. So now what we need to do is this is going to have to get glued onto the motor, which I don't like doing, but that's how they had it, not a problem. But I need to make this be attached. So where these threads are, as an example, this needs to be attached. And then this has to be relatively flush. So, let's brainstorm here. All right. So I'm thinking of a couple of different things. One, cutting off the threads and then gluing this or adhering this directly to the shaft. Pro, it's a direct fit. Con, most likely the glue is going to snap and then this is just going to spin freely. Other option is to bore this out, because this piece is the same diameter as the fat part of the shaft. Drilling this out and threading it on, which is probably going to be the best option. Con is because of the age of this, it's brittle, and I risk shattering it with a drill. But I think that's the way I'm going to go. So let's do that. Now how I'm going to do it is I'm going to use a really small drill bit, and I'm going to drill from the square side all the way through to give me a centered pilot hole to work on. And because this is a plastic, it's a hard plastic, I'm going to try and bore the hole to a little bit bigger than the center, but not as big as the thread. So there's just enough threads to cut as I slowly turn this on and cut new threads into this using these threads. And once I do that, we'll put a little bit of super glue, or I use Gorilla Glue, on the threads, and then that will be a Loctite to hold this in place. So it can't be unscrewed if you start spinning the skeleton. So, but on any of these pieces that use this plastic insert, which the Department 56 was good at doing, different styles, different shapes, but they still use a plastic drive on a lot of these older tabletop pieces. This isn't replaceable. So if you do break it, you're going to have to fabricable something. Now that's why if you ever watched any of the other videos, like the up, up, and away video, that 3D printed block that was used in that video is to replace a piece like this. That drill bit's too big. That drill bit's perfect. That's why there's that 3D printed block, is because the up, up, and away had a rubber-ish, plastic-ish piece like this, and it was just, they're always disintegrated. I think I had one that was still intact, but it's not compatible with the new motor, because again, they don't make the motor anymore, so you have to use the new style, so you have to use the block. It's just the nature of the beast. What I found out is a lot of these companies, they say we want to make 100,000 units. It's a little of an exaggeration, but it's a number to start with. So the motor company makes 101,000 motors. That way, in case any are defective, they can quickly replace them. But once those motors are used for the job, they usually throw away the motor mold and go back to the standard motors. And that's why there's no replacement OEM parts. Now, because the plastic's getting warm enough to stick inside the drill bit, I'm stopping after a little bit and pulling out the drill chips, so that way it doesn't crack what I'm holding. Be careful, you are holding a piece of plastic while a drill is drilling through it, so you definitely don't want it to slip and catch your finger. There we go, it's all the way through, in case you didn't see. There you go, drill bit's protruding out, so we're good. Now, we need to step it up. I wouldn't go full bore or full hog, or however you want to say the different variations of it. And the main reason is you don't want to get the plastic hot and you don't want it to crack, because again, it's going to be hard to replace. As far as fabric cobbling something, if you have any pieces of round plastic dowel rod, you could technically drill a pilot hole, get this hot with a lighter, and then push it in to make the square shape, and then before it cures, pull it back out, and then you'll have your new shape, your new square for the drive for this. Just use a plastic dowel. You can get them online. I think some hobby stores sell them, and I think some hardware stores sell them too. I don't think that's anywhere remotely close to the right size. Not yet. Just cleaning it out because a lot of the plastic is sticking inside. So this is a titanium coated grinding bit, usually used for engraving on a Dremel. I'm going to use it on here to slowly auger out the hole. Because it's a much finer cutter, it won't take out as much material and give me more control, because I'm going to be using it to literally bore the hole out in a circle, because if we're going to make the sidewall so thin, a drill bit could crack it and shatter it in my fingers because of the chips that build up. So we're going to try this and see if we can do this without breaking it. I think I'm going to go to one size larger, maybe 2 sizes. Yeah, 2 sizes larger. You can use a small drill bit and do the same thing. It's just, I want to see if this works a little bit smoother. And I'm going to bring in a little extra light, which might flood out the camera a little bit. Yeah, not too bad. That way I can see better. Close, but no cigar. Now I'm making sure that I'm rolling it on my thumb and forefinger here, and I'm making sure that the cutting bit is pressing down against my thumb. That way I don't blow the side out. So I'm compressing the bit like so. So as I'm rolling it, I'm keeping my thumb down so I don't blow the sides out. It is not a fast process. The hole is much larger now, but still not big enough, so I'm going to go to another size bit. The reason I'm not doing a Dremel, even though I have a Dremel that will spin this slow, is control. The drill is planted on the ground or the table, and I don't have to worry about 2 hands. I just keep it planted, keep my finger on the trigger at a slow speed, and then just roll it. So. It is getting really close to where it'll work. Oh, I think I might have it. Nope, I need a little bit more. It's almost there. So this does take a little patience if you're still watching. Had a few complaints that the videos are long because I show the tedious stuff. But I want you to see what I do so it helps you if you have to do this. And there's one other option versus getting a plastic dowel. A wood dowel might work too. Just drill a hole in it. so you can thread it. It'll drill a lot easier than plastic. And then same thing, drill a pilot hole that's slightly smaller than the square, and then get that super hot and push it in. It'll burn the dowel. Pull it back out, and there you go. So the wooden dowel might work as well. It's probably a little bit more forgiving. Might have to try that in the future. These are left-handed threads, so that's why it looks like I'm making it go loose. It's righty-loosey, lefty-tighty. It's almost there. Just a hair more. I don't know if you can hear the background noise, but if you can, it's the neighbors having some work done outside, so you hear a saw going. So it's a rather loud saw since he's cutting steel. So the bottom fit, but farther up didn't fit because when I was cutting it, I wasn't holding it square, so it made a kind of a conical shape, and the threads aren't conical. So I had to cut deeper inside. There we go. It's as far on as it'll go. Let's see. Ooh, it sticks up a little bit. Maybe that. There you go. Yeah, just a hair. I don't know if that's going to make much of a difference. It's not technically screwed down all the way. It's still got a quarter thread, but that's not enough to make it go in. But because this thing is brittle, I don't want to screw it up anymore because it's kind of thin. So we're going to leave it there. I'd rather have it stick up just a little bit than shatter. If you're wondering where this little kit came from, it came from Tiva. It's designed for engraving metal and grinding fine metal. I didn't buy it for metal. I bought it for these resin houses. I figure even if it's cheap, it'll work fine on a resin house. All right. Pardon the noise for a second. There we go. Clean workspace is a safe workspace. That's what I used to say when we would work in the shop. Because if any of you ever worked in a shop or your garage and you got junk on the floor, you slip. Just going to put a little bit around the base. So the flat part as a filler once it's threaded on. Now we're going to carefully thread her on. Looks pretty good. Now I'm going to need some wire because you can tell this doesn't have any. I can cut it off the old motor, but I'm just going to take a section from the rule I have up here. So cut, cut, and cut, cut. So if you have this piece, maybe you'll get lucky and actually get the right motor. Maybe you'll find an old stock piece, or maybe you'll find a parts piece, or maybe you just find the motor. Somebody has a replacement that I couldn't find. I didn't look everywhere, I just did some basic searches and it just cross-referenced the different things. So I recommend soldering these, even though there's a hole that you can fish them through. Use the hole to fold the wires over and hold them. The problem is, as you can see, that wire still moves. You could technically trim off a lot and then do a Western Union twist to make it tight, but you risk arcing. Even though it's relatively low voltage, even low voltage arcs, and arc causes pitting, pitting causes corrosion, corrosion causes resistance, and then you start losing power. Little flux, not necessary, but I think it's going to help because of the amount of heat dissipation I'm going to experience. Plus you get that nice sizzle like you're frying up some eggs. Go. And I'm going to put heat shrink on those because if you notice, there's no protection on that bridge rectifier. And I don't want it smacking that and causing a problem like a short or an arc. So we're going to find some heat shrink that will fit over the tabs. It's too big. So I think these little black pieces here should work. That one's fine. That's fine. If you don't have heat shrink, you can use hot glue as an insulator. You can use electrical tape, liquid electrical tape. You can use, don't recommend it, but I've seen Lemax use masking tape. But if you have hot glue, it's the best outside of using heat shrink. Fighting the ceiling fan. Keep forgetting to turn it off. It's also because if I did, I'd get really hot. There we go. Said as much as I hate to do it, I am going to glue this back on. I just don't like gluing things to the motor casing. So I'm just going to run the glue around the mouth. This is where the brush comes in handier than the nozzle. I have both, or you can unscrew this and do it too. Get a little bit more control. Now, let's go straight down the center, kind of like the old game of operations. Don't touch the sides. Now, before this is completely reassembled and ready to be sent back, I am going to hot glue this out of the way so it's not flopping on the inside. And then we're going to clean up stuff like this where the hot glue is oozed over the edge. Yeah. Get a better readherence once it's done. So we'll get this ready. Next, let's strip the wire, solder it in, and make sure it spins. since that's had enough time to cure, bond. It's not 100%, but it's good enough to do this. I'm going to shorten these. Too much wire is just as bad as too short. Too much, the wire can get in the way of something and get caught. Too short, well, it's just too short. We all know what that means. It won't reach. But a little extra is better than not enough, but too much is detrimental. There we go. Get that wet. Saddle. A little bit of new solder. Get it to stop moving. That'd be awesome. There we go. Alright, first wire. My fat fingers are going to be in the way. And I think I'm going to use helping hands for this next one, and that's because the way the wires are, it's twisting it downwards, and every time it does, I can't work with it like that. And that's just the way the wires are. There we go. So that'll hold it up enough where I can get this one soldered on. There we go. There we go. All right, let's plug it in and see if it spins. It spins. You probably can't see it, so let's use a visual aid. We'll refer that to this big old hook. There we go. And plug it in, plug it in. Cool, huh? Now, if I wasn't using insulated helping hands, that would have been really bad, just so you know. So what I do is, you can see this one's not, and this one is. I just put heat shrink over it to insulate the teeth. This one had it, but the broke off. But all you need to do is insulate the teeth with some heat shrink. I have another bigger one over here, trying to pull the corner in. Yeah, you can kind of see it, but it's also insulated from the factory. They call them soft jaws, so it doesn't mar up your stuff, but I use it mainly for electricity. All right, do some reassembly now. just make it snug so you don't break the plastic. I'm just going back and forth until it seats. Sometimes these wings are just a hair off of the old ones, and they have to walk them down with the screw. So now comes the part that everybody loves, prepping the housing. So since it takes a couple of minutes for the glue gun to get up to temperature, I'm just going to scrape off some of the big chunks of glue here so we can get this thing put back together and call this one done. So if you weren't absolutely bored out of your mind, hopefully this will help you with this one. I got this motor from Suntronics. This is a motor for one of the variants of the Fezziwigs Ballroom. Ballroom had 3 different motor options, and this is one of the variants. I just bought it to try it as a potential. As a matter of fact, it only showed up like 2 days ago. Yeah, you saw it was still in the package. I haven't even had a chance to see how I can make it work. Well, now I know how I can make it work. So I will link below Happy Holiday Parts website, and then all you have to do is type in motors, or if you're looking for this specific one, just type in Fezziwigs in the search bar, and there's 3. This is 2 of them are 12 volt, and one of them is 120. They're all AC, so you don't have to worry about the type of voltage. And then you can pick if you want a right hand or left hand threads. I picked the left hand threads just to play with it, and that's why I said it's reverse threads. So he may have these back in stock or in stock under a different name. Some Department 56 pieces use the same motor in multiple things. A lot of their ballrooms use the exact same motor, so just list the Fezziwigs motor for the same ballroom as an example. Some of the Ferris wheels are that way too. You might have 16 different Ferris wheels, but they all use the same motor, so sometimes you can't list all the different variations. But I also gave you the ability to do modifications. Sometimes we have to modify to make function. It's getting warm finally. I'm like, man, this thing's taking forever. All right. Get all the gunk out. Go. Much cleaner. This is some residue and staining. There's one spot. There we go. There we go. Now we're good. This is nice and good. One little spot right here. So I am going to glue this up inside. I don't like it hanging, especially since it's exposed metal, and that's a metal motor. So I am going to see how this fits. Looks like it goes this way, so I need to glue this down here. So I'm going to have a little bit of a glue glob, and then I'm just going to press this into the glue glob and let it sit for a second. And I'm going to put a little bit on top to act as an insulator against the metal pins. Like I was telling you, so if this ever breaks free, the metal pins would swing and hit this. And even though it's low voltage, again, it's only 12 volts, I don't want it to ruin the... It would blow the lights. That's what it would do. It wouldn't hurt the motor. It'd literally just blow all the lights. We can reduce potential of damage in the future. We're going to take care of it right now. don't cut corners. Take the extra couple of minutes, do it right, and it'll last you longer. It's a lesson I had to learn a long time ago. I'm sure most of us out there have. But, all right. Now, my wires are stiffer, so it's not going to be as smooth transition to get it in. It looks like it goes right about there. Nope, it's off by just a little bit. Because of the angle, I got to adjust this plate just a little bit to compensate for that angle. Right there. There we go. So there's the position where it fits flush, and it comes through just a little bit. Now, depending on how lazy you are, you can just put a glue bead just as it sits, and it'll elevate the unit. Or what you can do, get yourself a marker. That didn't sound good. I don't know if you heard it, but that didn't sound good. And then just draw a little line. So now you know a reference point to put it back together. So that way you can put a full glue bead. I'm probably going to do 2 arcs, maybe 80%, so there's some prying room to take it back apart if the motor burns out again, or if this piece shatters, or if the resistor or rectifier fails. So I'm not going to do a full circle. I normally don't. I usually leave a little gap. Again, that's because everything breaks, and we want to be able to fix it. We want to keep this hobby going for as long as we can with the least amount of expense. And you push this in like so. We line up our mark like so. Of course, shift it just as I squeezed it. There we go. Now, let's get that out of the way. And let's see it work. Let's get our flying skeleton here. I really like the face. It's kind of got like that Evil Dead feel. And look at that face. And find the square, slide it in. There we go. And since it does light up, let's reduce some of these lights a little bit so you can get a better view. There we go. So I'm going to go turn off the other light. And I'm going to dim this one down a hair. There we go. There. So, here we go. We got a flying skeleton again. Alright, so you can see the pumpkins light up orange. There's 3. The skull eyes are a, oh, I forgot the color, but it's a light green. And then the tunnel is a dark green. These are like gallium something LEDs. They run at a much, much lower voltage. That's why they're not as bright. And they're not as intense green as that. So that's why we have those big resistors attached to that big rectifier. There's 3 sets of resistors for the 3 different colors. Dark green, light green, orange. There you go. So, there we are. That will conclude it. Sorry it took so long to get it done. 15 minutes is a long time to sit and watch this. If you sat through the whole thing, hopefully you learned something. Options as far as fixing it. If you can't find the exact motor, which according to most of the places I looked online, which I said wasn't every place, but doesn't exist anymore due to its age. And it is modifiable. I gave you an option with trying to bore out the bottom slowly. That's the longest and most tedious part. And then it's just sticking on a threaded shaft, which is easier than dealing with a shaft like this, where it's, you want to hit the skeleton, you know, flat or has a hole. But it'll work. Technically, you could do this too. That pole will fit inside of this shaft. It's not a tight fit. You can put a dab of hot glue in here, shove the pole in just before it cures, pull the pole out slowly. It'll make the square inside the shaft. And technically, you could use this. And then you'll just have, if you slide the green over it, you'll have a little bit of a gap. So it gives you some modifiable things. If you're going to use a threaded shaft, plastic dowel or wooden dowel, like I said, heat up this piece, shove it in one end after you drill a pilot hole. That way you can make it a square. You're basically making this into a swage to punch the circular hole into a square. The other end, just bore it to where it's just slightly smaller in the threads, and then just use the threads to cut into it. If it's plastic, it'll cut in easy. If it's wood, you'll have to cut, back off, cut, back off, and go on all the way till it goes down. If you have a tap and die set, you could use that, but that's a really small hole, so you may not have a tap that small. But other than that, that concludes this one. Any questions, put them below, but here we go. Fully functional, ready to go. Pack it back up, get it back to its owner. Until the next one, thanks for watching.